conference will now be recorded.
So, as we were talking about the so drawing in from our discussions in the last session, right? So basically, our objective over here was to understand the basics of impairment, right? And how is it that the probability of default, loss given default, and exposure at default flows in to help us capture this impairment, right? Or help us capture or help us form a predictive idea about this impairment, right? And in this attempt to explore this methodologies, we talked about, or we had classified the approach into two broad groups. First being the generalized approach, and the second being the simplified approach, right? And over here, so basically when we talk, so basically over here, the point that comes out is we need to understand. Okay, so am I audible now? Can you hear me? Hello. Okay, so as we started off talking about uh, the different approaches, right? So we tried understanding how is it that PD, LGD, and EAD would go in to capture the impairment. So when I talk about impairment, right? So impairment is, or so basically when I talk about impairment, right? So like we had defined in the last. So impairment is nothing but between the money that I expected to receive and the money that I actually received. So it's the difference between the contractual cash flows, the observed contractual cash flows, and the expected contractual cash flows, right? So the difference between these two would be our impairment, right? Now, now, when we talk about this impairment, right, so the question that comes out is how do we identify, how do we estimate this impairment? What are the different approaches of this impairment, right, of calculating this impairment? And we know that there are the two different approaches for computing the impairment. One is the generalized approach, and the other is the simplified approach, right? Now, for most of the common banking products like the term loans, be the credit cards, be your mortgage, etc., you have your generalized approach. And the reason that we use a generalized approach over here is that each of these assets that I talked about have a significant financing component. They have a proper interest component associated with them. Now, for assets which have a contractual cash flow but may or may not have, which may not have a financing component attached to it, is treated through the simplified approach, right? So, so the different kind of assets which fall under simplified approaches are trade receivables, lease receivables, contract receivables, and so on. So, so basically, what we now need to understand is that what exactly are the key differences between each of these measures, right? So, what is the difference between the trade receivable and a lease receivable? What is it that, so when do I say that it's a, so, so when do I use a generalized approach, right? So what should be, what type of assets should be there when I'm dealing with a generalized approach, right? So that is what we want to discuss in today's session, right? So how would our data for a simplified approach look like? So what will be that kind of the asset? What would be the asset class, or how would an asset class, how would data for a generalized approach look like? What would be the key variables? how would we identify, or what would be the key factors involved into it, right? Or what would be the key steps of developing a model, a generalized approach? What would be the key steps of developing the model of a simplified approach, and so on. So, so this is what we are trying to kind of explain in this discussion, right? So up to this point, is it clear? So is my voice loud? So is it clearly audible now?
Yeah, Tanmay, it is audible. So what you meant here is that we have a simplified and standard approach to calculate, to select the model
Not
based
standard
on
approach. No, it's not a standard approach. It's a generalized approach.
generalized. So this is the approach which we use to calculate the impairment of an instrument, right?
Correct. So these are the two alternate approaches used to compute the impairment for different asset classes, right? So some asset classes which have a financing component attached to it in the form of interest rates. So let's say, when your contractual payment involves both interest and principal. For such asset classes, we use the generalized approach, and assets which have the cash flows which are of the form of trade receivables, where only you have the principal which is paid to you over a period of time. For such assets, we use the simplified approach, right? So, depending on the asset classes, we choose that which of the approaches should ideally be used. So, that is what the entire idea is. Okay, fine. So, the first question that comes out to us is that how would a data for a simplified approach look like? So let's start off by looking at this. So this data set that I have over here is the data which pertains to an automobile industry or an automobile loss forecasting data, right? So this is the automobile loss forecasting data, right? So when I talk about automobile loss forecasting data, so this is basically, or more specifically, this is a leasing portfolio, right? So so there is this financing house, which has given the loan, or which has leased out the respective automobiles, or they lease out automobiles for that, right? For people to use, and basis that they receive a contractual revenue, right? So that there's a contractual payment which they receive. So this is automobile loss forecasting data, right? Or let me put it like this: this is a lease loss forecasting data. Loss, I'll not put it as forecasting, I'll say it's loss data, right? Okay. Now this data is from 31st 10 to 31st 14. So this is a pretty old data set that I have. You can obviously change this data as per your requirement. You can change the dates in the data as per your requirement. So the date is not really important over here. So what we have is a data from ranging from Jan 2014 to Jan 2010 to Jan 2014. So there are like 4 years of data roughly. Yeah, so there is 48 months of data, right? And so this data talks about the total exposure which is outstanding, right, and the monthly loss that they have incurred from the respective balances, right? So basically, out of this balance, so this is the outstanding balance, right? So the loss that this firm would incur from this balance will not only be this loss, but so my objective is to predict or is to have an understanding of at least the next 12 months loss, right? And from there, what we need to do is we need to convert it to a lifetime loss, right? So over here, when I'm doing the simplified approach, because I do not have any staging exercise, right, I need to compute the lifetime loss, right? Or I would aim to compute the lifetime loss. So over here, if you have a look into this portfolio, so it shows that so it shows the respective outstanding that the portfolio has at each month on a month-on-month basis, and the loss that they earn from here, right? Now, from this figure, what is prepared is a next 12 months loss. Now, the next 12 months loss is a figure which is captured by adding up these monthly loss figures for the next 12 months and reporting it at this date, right? So over here, let's say I'm standing as on 31/1/2010, right? So from here, what I want to do is, so I have these 12 months of loss, right? So if I add these loss figures up, I should ideally get this loss. But there may be a difference that these losses that are reported over here are your gross losses or your gross charge-offs. And over here, the next 12 months loss is the loss, right? So this loss is your maybe your net charge off. So obviously, what our objective over here is to understand what or is to predict the lifetime losses for this particular portfolio, right? So the question that comes out over here is that what exactly is the, you know, so what exactly is the loss rates or what exactly is the exposure for this particular account or this particular portfolio? So basically, if you have a look into this, so this is this portfolio is like $169 million portfolio, right? Or sorry, it's yeah. So yeah, so it's $1 billion portfolio. So from here, what we want to understand is, or what we want to know is, that what exactly is the losses and how is it that we can actually predict the losses for this portfolio. So I need to predict the next 12 months loss and I need to predict the lifetime loss, right? So from that I need to go to the I need to essentially frame the lifetime loss, and from there I need to actually check that is the next 12 months loss a better prediction, or is it that the lifetime loss which is a better prediction for this data, right? So now after this next 12 months loss that you can see, so it's a summation of the loss figures that are there, right? And so what we generally do is we put in a monthly loss percentage, right? So the monthly loss percentage is nothing but B6 by C6, so the amount of loss divided by the outstanding balance. So this monthly percentage loss, right, is nothing but, if you think about it, this is nothing but the loss given default, right? So the amount or it's the charge off rate or the charge off percentage, right? So this is basically your, or this you can treat this as your observed LGD figure, right? And over here, what you do is you compute the next 12 months loss and you check what is the overall loss percentage. right? So this is what the overall data set is. Now, given that I have an outstanding balance and I have a monthly loss reported, so monthly loss is nothing but it's your impairment figures, right? Now, what I want to do is I need to sit down and I need to develop a model which will help me predict the expected credit loss in the next 12 months, and then it will help me predict the lifetime ECLs. So the question that comes out over here is that how do we go ahead doing that, right? So is this data clear to you? Is this data set clear, guys? Okay. So I have in the next step, I have the data dictionary reporting each of the variables, right? So month is your as on date or your reporting date. Outstanding balance is your balance outstanding as on the reporting date. Monthly loss is the gross charge off, which is recorded at the reporting date. The next 12 months loss is the sum of the next 12 months loss reported at a given reporting date. Then what you have is the monthly loss percentage, which is the gross charge off as a percentage of total outstanding at the reporting date. Then you have the next 12 months loss percentage, which is the percentage of the total outstanding balance. And finally, what you have is probability of loss in the next 12 months. And finally, the expected credit losses. Now, the question that comes out over here is that how is it that we would develop this model, right? So how is it that this model can be developed? Now, so over here, this development framework that I have over here is is very it's a generic way that I have talked about, and it was an estimation process which I had used for some other purpose. But so basically the way we have talked about this is something which is so the model, the quality checks and also that would change because the type of the data that I have over here is very different. But the overall steps of development would remain more or less similar, right? So if you have a look into this, so first of all, again, so we start off with the scope analysis, right? And in the scope analysis, what we want to say is, what we want to talk about is why is it that we need this particular, why is it that I need to compute it, or why should I be computing this portfolio with a simplified approach, right? And why not a generalized approach, or why not some other ways, right? So that is the first point that we need to talk about. So it says if we explore the importance of the expected credit loss model and the IFRS9 framework to be developed for the business, right? And we start off with the overall picture of the portfolio. So what I need to identify is that why is it that a alternate approach is required when we already have next 12 months or observed next 12 months loss figure with from the data, right? And why is it that we need to predict it using something else, or why is it that we need a lifetime loss approach to do this computation? What are the challenges that we or the present methods of estimations are facing? So to answer that, the first question that we need to address over here is that why is it that, or what is it that the present method of estimation is, right? And based on that, we will try to create an explanation as to why the IFRS 9 simplified approach is to be actually used, right? So that's what the scope analysis would contain. First, we'll talk about the nature of the asset class. Then we'll talk about the present method of estimation which is used. And from there, what we'll talk about is why is it that we use the lifetime ECL approach, right? So then what we do is we talk about the data quality checks. So in this case, the quality check, because it's a univariate data and there is a single loss variable, a single outstanding variable there, right? So we would not be required to perform a very exhaustive data quality check, right? The reason being that the data is already in the variable, right? So we don't need to do such variable level analysis. All we need to look into is into the trends that this variable has, and based on that, we can take our decisions of developing the respective models, right? So over here, we will be, so when we look into this data, so when we do the quality check exercises, right, we'll try to examine key shifts which may have happened in the portfolio. So does the portfolio report any major shifts which may have happened? So that is something that we would want to identify, right? So going forward, that is something that we would want to identify. So, so over here, the variable exclusions, first occurrence, last occurrence analysis may not hold or would not hold, given that you just have a receivables data over here, right? Now from here, the next question comes out is a model development and then of model validation. So over here, the idea is to identify the distribution of the outstanding balances across the different delinquency buckets. So if I have a trade receivables kind of a portfolio, so let's first understand what exactly is a trade receivables. Let's say I am a food manufacturer, right? I supply raw meat to the different stores across different multiplexes, right? Across different malls and across different eateries. Now, when I'm supplying my meat, I do not do it on cash. I do it on credit, right? So there is a receivable which I am bound to get from the other guy. Say 2 months, 3 months down the line, 2 months down the line, 1 month down the line, and so on. So if I have it at the end of 3 months, right, so what happens is he pays me a certain amount every month. So he divides it up into 3 months of installments and he pays it to me in a month on month basis. But when he pays me, he doesn't pay me any interest along with that, right? So he just pays me. If I have sold him goods worth 3 lakh rupees, he would pay that 3 lakh to me in 3 installments, right? So, so that is precisely what the idea is. That I would require. Okay. So, so over here, what we are trying to do is, uh, yeah, as I was saying, so this guy pays that 3 lakh rupees to me in an installment of 3 months, right? Now let's say if he misses out paying the first installment of my receivables, right? So he goes one cycle delinquent. So it goes on like this, right? But when he pays back, he doesn't pay me any interest along with it. He just divides that entire money into 3 parts, and he gives me and he pays those 3 amounts back to me. So this is the way this entire thing works. So so over here, so if you see this flow, the cash flow is contractual, right? But it does not have an interest component to it. So therefore, you cannot divide it into stages, right? You cannot say that okay, this guy has undergone a credit deceleration because the entire calculation, the amount of the interest calculation in the generalized approach is based on the interest and the principal payment, right? But because there is no interest, you cannot do that calculation over here, right? And hence, this approach is called the simplified approach, right? So, what I need to understand over here as a modeler is that how is it that the balances are flowing across the buckets, right? So at every month, so whatever the total outstanding is, that total outstanding will lie in one of the, or will lie in one of the delinquency buckets. So some of these total balances may be your CB0 bucket or non-delinquent balances. Some of them may be one cycle delinquent, some of them may be two cycle delinquent, some of them would be three cycle, some of them will be 4+, right? So I need to identify the kind of a distribution which is there, right? So, so one very important precondition for developing a simplified approach is that the entire thing, the entire trade receivables data should be divided, or it should be like it is divided across the balances, right? So, yeah. So when we are trying to develop this, when we are trying to develop these models, so what we want to do is that I want to understand how the flow rates are happening, right? So let's say I have X, a balance of rupees X in the CD0 bucket, right, as on Jan. Now, out of that CD0 bucket, on an average, what is the flow rate to the loss bucket? So, out of those accounts with the CD0 in Jan, what is the flow rate to the loss buckets? So, this is where this asset class comes into play, right? So, this is where we say that, okay, the trade receivables X in this month, and out of that X rupees, some percentage go to the loss bucket. So on an average, out of X balance which is there in the CD0 bucket, Y percentage of it always flows to the loss bucket. So the loss rate for the CD0 bucket on an average would be that Y%. So I know that if I have a balance of CD0 of rupees X in CD0, out of that Y% is going to end up in loss. So that becomes my expected credit loss. Similarly, I do it for CD1, I do it for CD2. Now, once I have that overall picture, right? So once I know those flow rates, that those average or those representative flow rates to the loss buckets, right? I can now say that, okay, if I have rupees 10,000 in my CD0 balance, my CD0 bucket, and I know that 1% of this will go into loss. So 10,000 into 1% is the amount which is going into loss. That is rupees 100 goes into loss. So my ECL for this CD0 bucket is 100. Then in CD2, I have say 8,000 rupees. Now, out of 8,000, 2% goes into loss, right? So 8,000's 1% is 80 to 160 rupees goes into loss. So out of that 260. So my expected credit loss becomes for the next 12 months or for the lifetime becomes 260. So like this, we compute the next 12 months loss, right? First we compute the next 12 months loss. Then based on the maturity, we convert it into lifetime losses, right? So what I say is that, okay, in the next 12 months, this is what the scale is, right? And if I assume a symmetric flow rate in the next year as well, I can convert it down, I can convert it back to my lifetime losses. So if I know the time for which the loan is going to persist, I can compute back my lifetime losses. So this is something which we can actually do, right? So So one very important prerequisite for a simplified approach model is to know the distribution of an outstanding balance across the multiple buckets of delinquency. So this is something which is really important. Now comes the next part. So what we do is we first develop the model, right? And then using that model, what we do is we score the historical balances and we see what should the ideal ECL be, right? So that's the kind of validation that we do. So typical kind of 70-30 split and validation is not required at our end. So now over here, the entire data is laid out, right? And there are certain assumptions based on which this data has been created. So now I'll give you a background to this. So the origin of the raw data that I had only had the loss balance, the losses, and it only had the outstanding balances. So it did not contain the bucket-wise distribution of the balances. So over here, what I have done is I have created a bucket-wise distribution of the balances, right? So if I have created a bucket-wise distribution of the balances, then so once only I know that how the balances are distributed, right? After that, I can compute the ECL figures. Clear? So just let me explain this data first, and from there we will talk about the loss buckets and everything. Right? So we'll talk about how this ECL is computed and what are the other figures over here in this data set. Okay. So this data that we have, right, contains the following critical fields. First is it contains the total outstanding balance, right? The total balance, the total monthly balance for each month, the outstanding balance, right? Okay. So we have the outstanding balance, right? So over here, what we have is, so basically what we talk about is we have the monthly information, then we have the outstanding balance. Now, now what we also have is the loss. So basically we compute the loss rates, and from there we try to find out how is it that the loss buckets, or how is the ECL is computed. Now, apart from this, apart from the information about buckets, there is also a ECL figure or a ECL approach mentioned over here. So, which is or that ECL was computed using the Basel estimates, right? So basically, what at the end what we do is we had the Basel PD, EAD, for this portfolio. We'll develop it using the IFRS9, right? And then we benchmark each of these two approaches, and we'll see that which one gave us the better estimate and what are the pros and cons of the ECL computed with these two approaches. So that is something that we will be looking into, right? Okay. So let's look into the third column, which is column D. Now in column D, I'm talking about a percentage balance in the CB0 bucket. Now you would see that all these balances are all the values aligned between 80 to 90%, right? So what we have done over here is I'll tell you the logic behind this. Now whenever there is a business, right? So whenever there is an outstanding balance, and if the business is in a proper shape, right, you would see that the majority of the balances are CB0, relatively less amount of balances are CD1, and balance CD2 onwards to higher bucket, like 3 to 4% of the balances is concentrated to the higher. Otherwise, it is the other way around, then the business is actually going for bankruptcy, right? So over here, what we see is that nearly 85 to 90% of the balances are concentrated within the first two buckets, right? And nearly the last three buckets will comprise something of the 2.1%, like 4 to 7 to 10% of the balances is distributed between the last three buckets. And the first, and the 90% of the balances are concentrated within CD0 and CD1, out of which CD0 contains the majority of the balances, right? So with this assumption, what we have done is we have computed this CD0 bucket. So the basic idea behind these four columns is to break this, to break the values in column C into four different columns, into five different values. So when you add up all these five values, that is, when you add up these five values, you will end up with this value, right? So these five columns show the distribution of this outstanding balance, right? So is this part clear? Perfect. So this is the total outstanding balance, and this is the this is the distribution of these balances across, right? Now the next part that comes out over here is the month. So on a month on month basis, how is it that we are going to do? Fine. Okay, so before we move on to this, so before we move on to this, so just give me 5 minutes time and just be back and we'll take it up from there, right?
This conference will now be recorded.
Okay, hi. Okay, fine. So as I was saying, hey, hi Anshul, hi Harish, both there. Perfect. Perfect. So as I was saying over here, right? So what we did was we had divided the balance across the buckets, right? So what it says is that, so my assumption is that anywhere between 80 to 90% the balances lie in your CD0, like 10%, 10 to 5 to 10% lies within balance CD1, and balance two taken together totally comprise maximum between 10 to 15% of the balances, right? So that's the way it has been done, right? So basically what I get is when I cross multiply these two, I get the CD0 buckets. Now if you want, you can hide these rows and you will get to see these buckets after this total balance, right? Now over here, so CD0 is the current bucket. So it means that the balances which are current has not entered into the stages of delinquency. CD1 is between 1 to 30 days past due. CD2 is 31 to 60 days past due. CD3 is 61 to 90 days past due. And CD4 finally is greater than 90 days. So basically, as per the IFRS9 definition, if a loan hits the 90 days past due bucket, 90 plus DPD, then we know that yes, it's a bad bucket. So it's an impaired balance. So after this, so from here, what we have is we have the loss rates, which is so. So now my objective is that okay, out of here, so when I was stand when at the beginning of Jan, when I was standing there, right, the balance was CD0 balance, right? So I was standing, I have this much. Now out of this, right, so out of this, some amount of balance had flown into the 90 days past due, right? So the balances which are CD0 in the month of Jan, they will become, so some of them will become CD1 in the next month, right? Some of them will become CD2 in the next month, CD3, and finally they'll become CD4. So balances which were CD0 in the month of Jan, right? They will become CD4 plus in the month of June, in the month of April, right? And with every time, as I move across, as I move across this balances, right? So like this, as I move across there. So this is Jan, Feb, March, April, May. Yeah, the month of May, right? So, okay. Okay, so this is to CD4 plus, right? And from here, what we get to see is that how much of the balance flows to your loss bucket. So what is your loss bucket over here? Your loss bucket over here is the loss that you have on monthly, right? So if you go back to this data, so this is your monthly loss, right? So out of the total balance, this is the amount which has gone down to loss. So basically, what you are doing over here is, so for balances which was CD0 in that month, right? So they or so what you need to know is that for that month, how much the balances had gone into losses. So basically, what you are trying to do over here is that this. So the monthly loss was this much. Mhm. Okay, so yes, so what I'm trying to understand over here is that okay, this was the amount of balance that I had, right? out of this balance, how much of the balance resulted into loss, right? So over here, you know that. So for this month, this was the amount of loss which was there. So the balance which had flown into loss buckets, right? So corresponding to this outstanding, this was the balance which had flown into the loss buckets. So if I can find out the CD0 balance, so I would know that out of this, this is the amount which flowed to the loss buckets for that month. So over here, this is how the loss rates were decided, right? So so this is how the loss rates were decided for these buckets. So over here, if you have a look into this, you'll see that you have a whole distribution of the loss rate buckets. Now, from this whole distribution, what you can do is you can figure out a representative value of the loss rate for this portfolio, right? So you have the loss rate CD0, you have the loss rate for CD1, you have the loss rate for CD2, you have the loss rate for CD3, and you have the loss rate for CD4. So for each of these, what you can do is you can actually plot this graph, right? You can actually plot this. And from there, what you can do is you can identify the so you can identify how is it that this distribution would look like and what should be its average values, right? So you can do a simple analysis of that, and from there you can decide how to choose the representative behavior. So one thing is that now, so one thing you may do is you can look into the mean median mode value, and if you see that it's more or less symmetric, you can use the mean value, or to be on the safe side, you can also choose, if you see that it's more or less symmetric, so if it's skewed distribution, to get a very representative picture and to do away with the biasness in estimates, you can easily choose the median loss rates for each of the buckets, right? And from each of those buckets, what you will get is how is it that this simplified approach is done. Right, so let's go into this next part. So are you clear about this loss rates, right? So with the outstanding balances in the raw data, we also had information on the monthly loss. So out of that balance, how much has gone into the loss rates? So how much has gone into loss? So if I divide that loss balance divided by this current bucket balance, what I'll get is my loss rate for CD0. Right? So is this calculation clear? Okay. Okay. Hey, hi Pradeep. After quite a long time. All good? Okay. Fine. So this is how, so the loss rates are computed. Now, one thing is that on a month-on-month basis, I can actually compute the ECLs, right? But when I'm computing the forward-looking behavior, right? So at that stage, what I need to do is I need to have a clear cut understanding. I need to have an average figure, right, for the portfolios. So over here, I have multiple loss rates, right? So I cannot do it like this. So I need to have a specific value of the loss rates, which would help me, capture the next 12 months loss rates and so on. So using this, I should be able to capture that, okay, so balances which are in CD0, right, have this percentage or have this flow rate into the loss buckets. Balances which are in CD1 will have this flow rate into the loss bucket. Balances in CD2 will have this flow rate into the loss buckets. Like this, and finally balances which have hit the CD4, they will be capped to 1, right? So basically that's where I would say that fine, this balance has hit CD4 or CD4 plus, so it means it is already going in. So balances which are say 90 to 90 to 120 days are a huge proportion of them would be flowing into the loss buckets. So that's the way we are that's the way we would be trying to do it, right? So let's have a very quick look into how is it that we could identify the balances which are flowing into the loss rates, and so what exactly are the flow rates like. So, so a few things over here, right? So uh, I know that so there are so basically, what I can see over here is that there is some. Uh, so basically, what we have done is for each of them we have computed the expected loss. So given the balance and the existent the flow rates, we can compute the ECL for each bucket. But these values must be multiplied by one single constant for a portfolio, and that is the reason why we need a representative loss rate figure. So that if I stand today and I know that okay, this is the flow rate in the next 12 months, so this is the flow rate over the lifetime. What I'll do is I'll just multiply my present balance by the flow rate, and I'll get the amount that can go into impairment in the next 12 months or may end up with a lifetime impairment. So that's the way this distribution is created over here, right? So let's go back and so before we enter the macroeconomic model, we insert okay. So it's representative loss rate analysis. Representative loss rate analysis. So if I just look into this, Okay, so over here, so now if I want to compute the loss rate, right? So CD0 loss rate. So what I want to know is that how will this loss rate be computed, right? So I need to find out a representative figure. So the average is 0.05. So what we'll do is for each of these, we'll create a descriptive statistics tab. So we'll run the descriptive analysis for each of these series, right? And we'll see how is it that this series works out, right? And once we have seen that, the next thing we'll do is by analyzing the descriptive measures of each of these series. The next thing that we'll do is we will try to compute, we'll try to summarize the loss rates. And once we get the loss rates, so given a balance in the next 12 months, this is what the loss rates are going to be like, right? And from there, we will convert it to a lifetime PD estimate. So basically, the question that comes out is that what exactly is going to be the lifetime ECL? So that's the computation that we need to do next, right? So, so let's start with the first one, right? So if I go to data, so I go to my add-ins. Okay, so first is uh, the descriptive measures. Over here we have the loss buckets. Mean, I'll put in median, average, so more or less the median and the mode are coming close. Median is coming close by. So we're looking at the mode now. So similarly, what I'll get to see is, okay, so the mode is kind of undefined over here because there may be multiple such values, which is valid to the mode. But more or less, what we get to see is that each of these distributions are, kind of they're pretty symmetric, right? So basically, with the median, but all the values mostly to some extent they are kind of right skewed because the median is more or less more than the more mean is slightly more than the median values. So, by if we have a look into this simple analysis, we can clearly say that yes, this particular variable or the loss rates are more or less symmetrically distributed, right? But it is always good, but the median is kind of slightly more than the median value, mean values, right? So it's better that we use the medians, right? So this is where the median kind of comes out, right? So, but again, one side you see that the median values, the rank ordering kind of breaks over here. So from that perspective, again, CD to CD4, etc. So this is where the loss rates or the flow rates should come in again, right? So and from here we should be able to identify that yes, this is the balance which is flowing in, and from this perspective, the mean balance seems to be a better capture of this loss distribution. Right? So when you multiply each of these values with the standing exposure, what you get is your next 12 months loss rates. But these flow rate figures are kind of your so what should I say? So these flow rate figures are kind of your portfolio. So instead of the portfolio, right now, the next thing is they need to be adjusted to your macroeconomic factors to make them forward-looking and point in time. So that's the next part that we will need to do, right? So let's stop here for the day, right? And let's catch up next week. So in next week, when we come back, we'll complete the simplified approach, and from there we will talk more about adjusting macroeconomic variables. We'll see how macroeconomic variables are actually being adjusted. What are the different other portfolios where this is used, and so on, right? And from there, once we have a grip on the simplified approach model development, from there we move to talk about the generalizer approach as well, right? So this is precisely what we have. This is more or less precisely what we can do for our model development in IFRS9, right? So it's pretty simple. It's not a very complicated exercise. So we'll take up we'll do two, three more of these types. Then we'll go on to discuss the generalized approach. Right? So thank you
Yeah.
guys. Thank you for your time. Yeah.
Just a question here.
Uh-huh.
Yeah. So, how many videos? I could see there are 11 videos on the Google Drive for
Yeah,
IFRS,
so
right?
those 11 videos, yeah, so those 11 videos are the net of videos that you have, right? So there were some videos where the recording was not good and all. So those are the net 11 videos in a sequential manner which covers the discussion that we have done till now, right? So you have all the content that we have covered in those 11 recordings. So after that, the next recording will be on this simplified approach that we have done.
The today's recording is pending only, right? So the today's recording is pending only.
Yeah, today's recording is pending.
But last week also
Yeah, so we met last week, but we dropped off in between, right? So
Yeah,
what I did was in today's session I did a recap of the entire thing
yeah.
that we discussed
Okay.
last week, and I got today's session. Yeah.
So
So
we
if you
have a
listen to
12.
today, yeah, so if you listen to today's session, you will have the entire end-to-end flow of what had happened last week and this week.
Yeah. So these 12 recordings for IFRS 9 is the crisp of what we have done up till so far.
Correct, correct. Yeah. So thank you guys. Thank you for your time, and let's catch up next week. Bye bye.